In this video, we're going to solve equations involving quadratic terms, and we'll be using the square root property. In example 5, we have a quantity squared equal to 16. So to undo the squaring, we're going to think about taking square root of each side of the equation. And that looks like square root of the quantity x plus 3 squared is equal to plus or minus the square root of 16. So it's important that we write both the positive and negative square root of 16. We have to consider both cases. So when you take the square root of a perfect square, those are opposite operations, and therefore any radicand will be released from the radical. So that leaves x plus 3 is equal to plus or minus the square root of 16. And since the square root of 16 is 4, then we have our quantity equal to plus or minus 4. Now we set up two separate equations to solve, and we should end up with two answers. First, we'll have x plus 3 equal to positive 4, and then x plus 3 equal to negative 4. Using the properties of equality, I can see that I must subtract 3 from each side of this equation to get x equals 1. In the other equation, I'm subtracting 3 from each side again, and here x would equal negative 7. You can substitute these values back into the original equation to make sure they work. Using positive 1, 1 plus 3 would be 4. 4 squared is 16. So I know that positive 1 works. Using negative 7 for the x value, negative 7 plus 3 would be negative 4. So the quantity of negative 4 squared means I have negative 4 times negative 4, and that does make 16. So both solutions work. Example 6 is very similar. We have a quantity x minus 7 squared equal to 81. So to undo the squaring, we're thinking square root on each side of the equation, remembering plus or minus square root of 81 on the right. So we have a quantity of x minus 7 squared under the radical, so the opposite operations are canceling each other out, releasing x minus 7 from the radical, equal to plus or minus square root of 81. Again, 81 is a perfect square. We know that will clear the radical as 9. So our equation now is equal to plus or minus 9. We'll go ahead and set up two separate equations. One where x minus 7 equals positive 9, and then x minus 7 equals negative 9. Adding 7 to both sides of the equation, we end up with x equals 16, and then adding 7 to each side of the second equation, we get x equals negative 2. Let's check these answers. Using 16, 16 minus 7 would be 9. 9 squared is 81. 16 works. Using negative 2 for the x value, negative 2 minus 7 would give us negative 9. Quantity of negative 9 squared means I have negative 9 times negative 9. Two negatives do make positive 81. So both x values work. In example 7, we don't see a quantity squared here, but I do see a term that is quadratic, or raised to the power of 2. So what we need to do here is first isolate the term that has the quadratic. That involves subtracting 20 from each side of the equation first. Negative 2x squared now equals negative 8. So we'll need to also eliminate this coefficient of negative 2. And we can do that by dividing both sides of the equation by negative 2. So those are reducing, leaving x squared now equals positive 4, because a negative divided by a negative makes positive 4. So we're ready now to take the square root of each side of the equation. Don't forget it's plus or minus square root of 4. So the square root will undo the squaring, leaving us x equals plus or minus 2. 4 is a perfect square. So now we can check both positive and negative 2 back in the original equation. So negative 2 multiplied by x squared. Negative 2 times positive 2 squared plus 20, does that equal 12? Negative 2 times 4 plus 20 equal to 12. So negative 8 plus 20 equals 12, and it does look like it works. 12 does equal 12. So positive 2 works. Let's try negative 2. For the x value, we're substituting negative 2 squared plus 20. Does that equal 12? So when we have the quantity of negative 2 squared, that makes positive 4. And notice how this equation is exactly the same as this equation. So we know we'll have 12 equals 12 again. So both positive and negative 2 work. Let's try the last example. Here we have 3x squared minus 88 equals 20. So you notice that the term that is being raised to the power is not isolated yet. So we must first add 88 to both sides. Now 3x squared is equal to 108. Since x squared has this coefficient of positive 3, we'll need to divide each side by 3. So now x squared equals 100 divided by 3. 3 goes into 10 3 times with 1 left over, and 3 goes into 18 6 times. We're ready for the square root property, so we're taking the square root of both sides of the equation, remembering plus or minus square root of 36 on the right, and we have x squared under the radical on the left. So the square root and the squaring undo each other. They're opposite operations. So we're left with x equals plus or minus 6. And we can check our answer back in the original equation. 3 times x squared would be 3 times 6 squared minus 88 equal to 20. Let's see if that works. 3 times 36 minus 88 equals 20. Now 3 times 6 is 18. Carry the 1. 3 times 3 is 9. Add one more. That's 108 minus 88 equals 20. Sure enough, 20 equals 20. So positive 6 works. Let's try negative 6. 3 times negative 6 squared minus 88 equals 20. So that makes 3 times the quantity of negative 6 squared would be positive 36. Minus 88 equals 20. Again, you can see this is exactly the same as the equation we've already tested, so we know that 20 will equal 20. Both positive and negative 6 work. This is how we can use the square root property to solve equations involving quadratic terms.